Have you ever flipped a switch and nothing happened? For most of us, reliable electricity is a given. But what if I told you that the vast, intricate network powering our lives is starting to crack under pressure? America's electric grid, a marvel of 20th century engineering, is facing a 21st century crisis. And it's not just about the occasional blackout during a storm. We're talking about a fundamental strain that could reshape our daily lives. So, what's really going on? Why is the system that electrified a nation now struggling to keep up? Let's unplug the myths and plug into the reality of America's power problem. First, let's appreciate what we're dealing with. The U.S. electric grid isn't one single thing. It's a sprawling, interconnected web of power plants, more than 700,000 miles of high-voltage transmission lines, and millions of miles of local distribution lines. It's often called the world's largest machine. For decades, this machine hummed along, powering our homes, industries, and digital lives with remarkable consistency. But here's the catch. Much of this infrastructure is old, really old. Some parts date back to the early and mid-20th century, long before a world of smartphones, electric vehicles, and data centers was even imaginable. Think of it like trying to run the latest high-speed internet on a dial-up modem. The hardware is simply not designed for the demands we're placing on it today. This aging infrastructure is more vulnerable to failure, especially when pushed to its limits. And pushed it is. The first major pressure point is climate change. We're seeing more extreme weather events than ever before. Record-breaking heat waves, once-in-a-century winter storms, powerful hurricanes, and widespread wildfires are becoming the new normal. Each of these events puts an incredible strain on the grid. During a heat wave, millions of air conditioners switch on simultaneously, causing demand for electricity to skyrocket. This can overwhelm power plants and transmission lines, leading to rolling blackouts to prevent a total system collapse. We saw this tragically in Texas in 2021 when a severe winter storm froze natural gas pipelines and wind turbines, plunging millions into darkness and cold for days. It's not just about demand either. Wildfires in California have been started by power lines, and in turn, utilities are now forced to preemptively shut off power during high wind conditions to prevent more fires, leaving communities without electricity. The grid wasn't built for this kind of relentless assault from Mother Nature. The second major pressure is the clean energy transition. This might sound counterintuitive. Isn't renewable energy a good thing? Absolutely, but integrating it into our old grid is a massive challenge. Traditional power plants, like coal and natural gas, provide a steady, predictable flow of energy. You can ramp them up or down as needed. Solar and wind power, however, are intermittent. The sun doesn't always shine and the wind doesn't always blow. This creates a problem of variability. When a huge cloud bank moves over a solar farm, or the wind suddenly dies down, the power supply can drop dramatically. The grid needs to be able to instantly balance this drop with another power source to avoid instability. This requires a much smarter, more flexible grid than the one we have. It also requires massive energy storage solutions, like giant batteries, to store excess renewable energy for when it's needed most. We're building these, but not nearly fast enough. Furthermore, building the new infrastructure for this transition is a bureaucratic nightmare. Let us say you want to build a new wind farm in Wyoming and send that clean power to energy-hungry cities in California. You need to build hundreds of miles of new high-voltage transmission lines. This single project could cross multiple states, private land, and federal territory. It requires navigating a dizzying maze of permits and approvals from local, state, and federal agencies. This process, known as permitting, can take a decade or even longer. Local opposition, environmental reviews, and conflicting regulations can stall or kill projects outright. So even when we have the technology and the investment ready to go, we're often stuck in a traffic jam of red tape. We have more clean energy projects waiting for connection to the grid than the total capacity of all existing power plants in the U.S. They're just waiting in line. The third pressure point is the electrify everything movement. To fight climate change, we're shifting away from fossil fuels in other parts of our lives. We're moving towards electric vehicles, electric heat pumps for our homes, and electric induction stoves. On top of that, the digital economy is booming. Massive data centers that power cloud computing and artificial intelligence are incredibly power hungry. A single large data center can consume as much electricity as a small city. When you add all this new demand together, all the cars charging overnight, all the homes heating with electricity, all the servers running, our current electricity demand forecasts are being blown out of the water. We're essentially trying to add a whole new floor to a building whose foundation is already creaking. Without a massive upgrade and expansion of the grid, we simply won't have enough power to go around. So, we have an old, fragile system being battered by extreme weather, struggling to integrate new, variable energy sources, and facing an unprecedented surge in demand. It's a perfect storm. The consequences aren't just an inconvenience. Blackouts can be life-threatening, especially for vulnerable populations. They disrupt businesses, costing the economy billions. And they undermine our efforts to build a cleaner, more sustainable future. What's the solution? There's no single silver bullet. It requires a multi-pronged approach. First, we need a massive investment in modernizing the grid. This means replacing old wires and transformers and building a lot more high-voltage transmission lines to move clean energy from where it is generated to where it is needed. Think of it as building a new interstate highway system, but for electrons. Policies like the recent bipartisan infrastructure law are a start, but experts agree much more is needed. Second, we have to streamline the permitting process for new energy projects and transmission lines, balancing environmental protection with the urgent need to build. This is a tough political challenge, but it's essential. Third, we need to accelerate the deployment of energy storage. This includes everything from large-scale batteries to pumped hydro storage, which acts like a giant water battery. Storage is the key to solving the intermittency problem of renewables, allowing us to use solar power long after the sun has set. Finally, we need a smarter grid. This involves using digital technology, sensors, and AI to better manage energy flow, predict demand, and quickly respond to disruptions. It also includes encouraging demand response programs, where consumers are paid to use less electricity during peak hours, helping to smooth out demand spikes. The good news is, we have the technology and the know-how to build a cleaner, more resilient, and more reliable grid. The challenge is one of will, investment, and policy. It's about recognizing that the electricity system is the backbone of our modern society, and we can no longer take it for granted. The next time you flip a switch and the light comes on, take a moment to think about the incredible and incredibly stressed system that made it happen. Building the grid of the future won't be easy or cheap, but failing to do so will cost us far more. It's time to get to work. Thanks for watching. If you found this video illuminating, please hit the like button. Subscribe for more deep dives into the systems that shape our world, and share your thoughts in the comments below. See you next time.